Right, so we first open, this is gonna come in Google Classroom, yes? So we open the document and we can read through it, but before we do that, we need to open a Desmos page, all right? Cool. Make sure that you've got an account because I'll want you to share your link to your work. Once you have done your thingy, I want you to share it with me, okay? So let's go back to the assessment. I'll put the assessment next to this. All right. So I've got Zap Automotive make and sell two types of electronic car, the STEM and the Lencio. This activity requires you to use linear programming to model the constraints given by Zap Automotive and recommend how many STEM and Lencio cars they should make. Okay. Now, let's have a look at the car factory can make a maximum of 160 vehicles per week. It takes 20 hours of labor to make a Lencio and 12 hours for a stem. Each Lencio uses 550 kilograms uh, I've done the weight. I need to do the contract constraint. And also flip the inequality sign. And the last two ones are X and Y need to be greater than 0. So flipped is going to be X is less or equal to 0. And Y is less or equal to 0. Okay. That's how my... Have we got this? Yeah. Wonderful. And now I need to enter the what? P equals 6,000. What was it? 8,700x. So 8,700x plus 6,800y. And let's get rid of that and write it at the end equals P. Add a slider for P. Okay, now if I move P to 10, can I see the P anywhere? No. So let's move here to how much? What do you think? Can we make $10 profit on cars that sell for 6,000, 8,000, whatever? Make what? Huh? If each one of them makes a profit of 6,800 or 8,700, so let's make it 20,000, huh? Yeah. Are we beginning to see it? Yeah. You see it? It's still in the negatives. Yeah. So if I go 7,800, 8,000, yeah, I make 0. Let's make this. Where would you go with this? Let's make it 100,000 for now. 1, 2, 3. Yeah. 2 million. 1, 2, 3. 1, 2, 3. Okay. Okay, now we're talking. Yes. And where does it enter the, where does it look like it enters the feasible region? At this point here. Yeah. Which means we can also do the following. We can enter here a table, and inside this, in the third column, we can enter 8,700x1 plus 6,800 y1. Yes. And now we can enter the the nodes. So I've got a node at 0140. I've got the next node at 4120. I've got another node at 6100. I've got another node over here at 9050. Yes. And the last one is 050. So which one looks to have the biggest profit? Huh? 6100. Yes. So we can go back and take a picture of everything we've got here. Yeah. So first of all, we've got we have the inequations, but we don't have this. Yes. So if I take a picture of this guy, yeah, I can insert that over here. Yes. And from the table, I can say that maximum profit is when they produce 60 Lencio and 100 stem cars per week. Okay, wonderful. So we ended up with, we've done the calculations, we've got a table of values, yes, and we also have at the nodes, the profit at the nodes, yes. You can also add here from the table above, we can see that the maximum profit is when they produce 60 Lencio, and yes, that profit is of how much? 1,202,123. Yes, and what's that? Dollars. All right, that's a complete answer. Are we all good? Wonderful. Thus, too, the profit margin for the stem car can be slightly adjusted, but that of the Task 2 is for excellence, usually. The profit margin for the stem car can be slightly adjusted, so that's the Y, but that for the Lencio stays the same. Investigate how the profit margin can be changed to allow a variety of different numbers of stems and Lencios produced by each different combination having the same maximum profit. Okay? Now, I'm looking at my, let's go here on the graph. And I look at these constraints. Having multiple solutions means that what? My objective function, that of the profit, is, get out, you two, get out. That is parallel to one of the constraints. Yes? Because when it comes down, yeah, if it is parallel to one of the constraints, it will overlap. And along that line, I'll have multiple solutions, isn't it? Yes? Yes or no? Now, let's take it out a bit. Which one of these three constraints, so the green one, the red one, and the blue one, which one of these three has the highest y-intercept? The y-intercept is actually the profit, the blue one. So I want to make this one with a similar gradient to this one, which is this guy here. Yeah? Is that it? If I take it out, yes, that's the one. Cool. What is the gradient of that? Huh? It's 20 over 12. Yes? Cool. What is the gradient of my objective function? Okay, so which one stays the same? Which price stays the same? The stem, so can be Because of what? Huh? This doesn't work because we cannot have point 2 of a car. All right. What other constraint can we use? Let's have a look at this. How about if I highlight this one? Yeah, is the next steepest. Yeah. What is the gradient of this? Okay. So let's go back. If we use the production number constraint, the gradient is, how much is the gradient for that one? No, that's the y-intercept. X plus y equals, what is the gradient? Minus 1, because if I move the x to the other side, yes, becomes negative 1. You get that? Negative 1. Cool. And now if I want to have, if we want the same gradient of negative 1 for the objective where Lencio keeps the where Lencio keeps the same profit of 8,700, yes, the new objective function is going to be 8,700x plus what? Here, the coefficients of x and y are 1 and 1 equal. So what do I need to do here to have the same gradient of 1? How much do I need to change into what do I need to change 6,800 to have a gradient of negative 1? No, 8,700 stays the same. Yes? This one, I need to change it into something which will give me negative 1. Huh? So how do I make this one here at the top, 6 plus y equals 160? So disregard the numbers, disregard the constants. So I've got x plus y, and here I've got 8,700x plus something y. What would make them have the same gradient? Yes, Costa, 8,700. 8,700 y is equal to p. Yeah? And now I go back to this, yes, and change the profit to 8,700, yes, and see how it fits there. The problem is now that where do I need to? So I've got this one, 40, 120. I've got another possibility here at 50, wait, 50, 110, 51, 109. See how many whole solutions? 54, 106. Yes. So if I go big like this, yeah, I can see that along here I've got 42 and 118. I've got 44, 116. I've got 46, 114. See how many multiple solutions for the same profit of 1,560. Yes, so I can just get some values in here. The profit, the new profit is 1 million. What did we say? 560,000. 560,000, and can be by producing and let's give a couple of values. So I've got, first I've got here 40, 120. 40 L, 120 stem. I can do 42, 118. 42, 118. What do you see? As Lencios go up by 2, so I can go 44. Lencios 116 stem, 40